admission controllers. So talking about the types of the admission controllers that we have, assessing Kubernetes objects, using admission controllers, how admission controllers work, and then the use cases. So my name is Tunde. I'm an engineer at VMware. So what are some ways of extending Kubernetes? So by extending Kubernetes, so Kubernetes by default that has a certain number of features, certain things you expect for it to be able to do. But sometimes your operational use cases require you to extend the platform so that it can meet your company's need or your use cases. So today there are a number of ways you can extend Kubernetes. One of the ways is using admission controllers. Another way is using CRDs or aggregated APIs. So CRDs are custom resources. And so they're more tuned towards creating objects inside of Kubernetes that you would like to take advantage of API conventions. So an example of a CRD would be you creating something like a network object. So you'll be able to run something like kubectl get network or kubectl get VMs. So that's an example of CRD. And then aggregated APIs are just like proxy API servers that run behind the primary API server itself. And all this is designed compiled prior to the life of your Kubernetes cluster. And then there are operators also, and there's also using kubectl plugin, extending by creating kubelet binaries in a different way also. So there's just so many ways to extend, but today we're going to be focusing on using admission controllers. So what are admission controllers first? So admission controllers are just a piece of code that has been written for the purpose of intercepting API requests to the API, and then they mutate or deny or accept those requests that are being made to the API. It's worth noting that this admission controller piece, the whole control done by the admission controller takes place after your request has been authenticated and authorized. So today, the default admission controllers that come in with Kubernetes, and most folks here might be familiar with this. So one is the namespace lifecycle. So if you're running inside of your Kubernetes cluster as an operator and you run kubectl to delete namespace, and you realize that your namespace doesn't get deleted immediately. So namespace lifecycle is the admission controller that is in charge of validating that all the resources within that namespace are deleted prior to the namespace resource itself being deleted. So it's also in charge of making sure that you do not delete namespaces like kubesystem and kubepublic. There's also the default storage class. So if you deploy a volume inside of Kubernetes or you make a PVC request and you realize how the storage class is being defined, it's because the admission controller default storage class is making changes to your request. Specifically, you'll see two other admission controllers here, mutating admission webhook and also the validation admission webhook, and which are the ones we're going to be focusing on. So admission controllers are split into two phases. There are admission controllers that work in a mutating way and some that work in a validating way. So a validating way is the namespace lifecycle. That is, it validates that all the resources within your namespace are deleted prior to deleting the namespace itself. Now, the default storage class, on the other hand, it's more of a mutating admission controller, because you deploy a volume and then by default that volume doesn't have any storage class attached to it. The storage class admission controller attaches a storage class to it. So some other admission controllers that you can enable inside of your Kubernetes cluster are like always pull images. So always pull images means that this is something you can take advantage of if you're running an environment whereby you do not want your developers or cluster operators to use local images that have been already pulled, and you just want them to continue pulling from your registry. Namespace auto provision. So today, if you create a resource inside of a Kubernetes cluster, and so if you have a YAML file and to create a pod, and you specify a namespace dev, and the namespace dev does not exist inside of your Kubernetes cluster, that request is going to be denied. But if you have namespace auto provision enabled as an admission controller, it would go ahead and create that namespace for you. Another popular admission controller here is pod presets. So pod presets allows you to make changes to fields inside of a pod object prior to the lifecycle of that pod. And then there's pod security policy also that you can use for enforcing security for your pods. So you can make sure that your pods don't run in privilege mode using something like this also. So how do admission controllers work? So today, as a Kubernetes operator, you make a request to the API server. Once that request is authenticated and authorized, then it goes through the mutating phase. And it makes sense to go through the mutating phase because you want your changes to anything that's going to make changes in a mutating way to go ahead and do that now. And then after the mutating phase goes on, we do something called object schema validation. So this is just checking that all the fields inside of your Kubernetes, so YAML is exactly what they should be. And then we go through the validation admission phase. So every admission controller that falls into the validating admission, this is where they take place. And then once the validation admission completes its work, then your object gets persisted into etcd. So far, so good. Does anyone have any question about like the process?
Actually, I have a couple of questions.
Go ahead.
So basically, admission controller is somewhere sits within this particular diagram itself, right? And it's some sort of a webhook, like you said. I mean, like if the namespace is not there, if you enable one of those controllers, then it's going to auto provision that particular namespace.
Yes.
So you're saying like after the HTTP, the API handler has got the request has been authenticated. Does it like mean like the phase 3, 4, 5, and 6 is all encompassing the admission controller?
Yes. So phase 3, 4, and 5. So that is from this point here, from this mutating phase right here, the admission controllers that fall under the group mutating admission controllers would make their changes here. So they would mutate any Kubernetes object they need to mutate. And then at validate, so object schema is, don't consider object schema as part of an admission controller behavior. This is just making sure that every field inside of your declarative file or your YAML file is exactly what they should be. And then the validation part is the one that does things like validating. So any admission controller that falls into the group of validating admission would take its place in this field. So if you notice, we have Webhooks here. The default admission controllers and the others that I showed you initially, they fall under a static admission plugin. So those are plugins that have been compiled prior to the life of a Kubernetes cluster. So it's been baked inside of the API server. So technically you can you can write your own admission plugin prior to and also bake it inside of the API server. But the challenge with doing that is, let's say a new version of Kubernetes comes out, you also have to go make changes to the admission controller. Let's say if there's a API version that's been deprecated, you would have to make changes to that API version also. So that is not too flexible. It's not something that could easily be changed or scaled. So that's why admission controllers, mutating admission webhooks are like a good use case because they are dynamic. That is, you can use them while your cluster life is up. So admission webhooks are just pretty much an HTTP callback that receives API requests and just does something with them.
And how do you enable admission controllers? So, like for example, I mean, like I have two Kubernetes cluster. One is running on my laptop. I have like a Minikube, and I have like one Kubernetes cluster running on a EC2 instance on Amazon. So, if I were to say, okay, I'm enabling, say, one of the admission controllers, what does that look like, or what does that actually mean?
Yeah, so that brings me to one other good reason why like admission webhooks are really a good thing, right? So let's say you're running on managed EKS right now, managed Kubernetes. So for example, EKS, GKE, and the likes of them. The problem with that is that you do not have access to their API code, and you cannot change it or write a plugin and set it inside of the API code. So you can take advantage of things like admission webhook, and the way to enable them is to go inside of your API server YAML file. That is the Kube API server YAML file, and enable the admission plugin. And by default, as of now, admission webhooks and mutating and validation webhooks are enabled by default. But as we go along, I will show how that works.
Okay, that would be wonderful.
All right.
Thank you.
Does anyone have any other question? Great. So you might ask yourself, why would you extend Kubernetes? So security purposes. So take, for example, there was a vulnerability earlier this year, the RunC vulnerability that Docker, a container with root privilege could isolate itself to the host that it was running on. With admission controllers, you can do things like enforce security by saying that no pod should be able to run as root. And then governance, you can enforce things like every pod with a certain label should run in a certain namespace, or no pod should have a CPU request or CPU limit over a certain amount. And the management aspect is that you can ensure that your YAML files meet a certain number of criteria. Like, so for instance, you want every new pod or deployment that is running inside of your Kubernetes cluster to always pull new images, or whatever images that you're running inside of your Kubernetes cluster, you want them to contain a certain kind of tag. So those are some really good reasons why you might want to extend Kubernetes. And I'm sure some other folks on the call might have different reasons why they're extending. I'll be very, very happy to hear while you extend Kubernetes using admission webhooks. So like I mentioned earlier, so there is a static admission controls, which are the ones that are compiled into the API server, and then there are the dynamic admission controls, which are the validating webhooks and mutating webhooks. So prerequisites for deploying an admission webhook is you have to ensure that your cluster is at least version 1.9 onwards. Ensure that mutating admission webhook and validating admission webhook admission controllers are enabled. And then you want to make sure that the admission registration is also listed in the API versions of your Kubernetes cluster. So basically, an admission webhook is just a webhook that is running on an HTTP server. And that HTTP server itself is typically fronted by, so there are two ways. You can either run the admission webhook outside of your Kubernetes cluster, or you can run it, you can take advantage of the deployment API and deploy the admission webhook as a pod inside of your Kubernetes cluster and front end it with a service. So here is a sample of an admission validating webhook configuration. So here we specify the kind, validating webhook configuration, and we specify the name of the object. Then we specify also the name of the webhook. Mind you, the name of the webhook has to be a fully qualified name. So an example, like you can see here, is podpolicy.example.com. So it could also be tunde.meetup.com. So it has to be fully qualified. And then the rules, an admission controller makes intercept requests based off the rules that it matches. So right now here we can specify the API groups. So this could be apps, this could be apps v1. And then we specify the API versions and then the operations that we want our admission controllers to intercept. So in this case, on every create of a pod, this admission webhook is going to intercept that request. So we can also have multiple operations here. So you can have another line that says delete. So today you can make changes based off create, update, operations that create, update, delete, and connect. So update is just kind of like you running a kubectl apply, trying to mutate, change an object state. And then delete is you trying to delete an object, and connect is like you're trying to run a kubectl exec. And then also you can scope a validation webhook to be namespace or just cluster-wide. Client config is how your webhook server communicates with the API server. So in order for the webhook server to communicate with the API server, it needs to communicate using TLS. So in this case, we're specifying that we're using, oh, not quite yet. We're specifying that we're using service. So this could either be service or URL. So URL is, you specify URL on this field if you were to be running the webhook server outside of Kubernetes. But if you're running inside of Kubernetes, you would have to use the service and then specify the namespace that service will be attached to, and then the name of that service and the certificate authority bundle that will be used to communicate with the API server. And then admission review versions and, 1 second, let's go back here. There's also a timeout second here, and I'm trying to make sure, yeah, there you go. Timeout second equals 1. So this is a new thing in 1.14, which is the amount of time that your your validation webhook would wait for to to return a response to the admission review request that it receives. So
And
admission,
is that,
go ahead.
sorry, two questions. Is that timeout only in seconds or it can be tweaked down to microseconds?
So right now, I believe it's only in seconds, and I also plan on showing you where this is listed inside of the code, so we should be able to drill that down.
Okay, and second question, is there any version or capability where you can actually have like a dry run capability for any of this? What's going to happen instead of admission controller actually doing its stuff, but more of like a testing it?
So I believe, yes, there is a dry run capability here. So
Okay.
you can also have a dry run field in here.
And what is that term that you're using? Sorry, I'm not very well versed with Kubernetes and other terminology. Feud? What is that?
Feud.
Feud?
So yeah, so feud. For example, like if we go back, let's go back. So name is a field inside of Webhook. Then rules is also a field inside of Webhook, and API rules and API versions are also fields of rules.
It's a field you said, right?
Yeah, field.
Okay.
Yeah.
Okay. Thank you.
Thank you so much for asking that. So the admission process. So today, like when you send a request to the API server, what happens is that the API, the admission control sends an admission review to your webhook server. That admission review contains the admission request, that is the request that is being made by the user. And inside that admission request, we have a JSON payload and also the UID, that is the unique identifier of that request, that is then exposed to your webhook server. And based off what your webhook server does is it makes changes to that based off the request using the logic that you've specified inside of the webhook, and then sends an admission response back to the admission control point. So the admission response is going to contain something like, specifically a couple of things that admission response will always contain is it's going to contain the result, and it's going to contain, there's a field inside of the admission response that is allowed. So if allowed equals to false, that admission response means that deny the request that you're sending to the API server. So if it's allowed, that is allow that request to go on. And then we'll still take a look deeper into what this looks like. So before I dive into, let's go back. Before I dive into the demo, I would like to show one more thing. So let's go down into, so let's go into the Kubernetes repo. And if we look at plugins and package and admission, so you can see all these static plugins that we talked about earlier. And so you can come in here and check out, so there's port presets, for example. And also if we go back and we go into package and APIs and admission, and then we check types.go. You can see information about the admission review I was talking about earlier. So it contains the admission request and the response. And inside of the admission request, we have that UID, that is the identifier for individual requests/response. And also the request kind. And then there is also the namespace and the user info and then objects. Then the dry run you were talking about is also here. So does this clarify that, Arun?
Yes, I mean, like, this is very informative. Just have to play around with this.
Yeah. So in the admission response also, so when I mentioned field, there's a Go concept called structs. So it's just like data. What's the equivalent in Java? So they're like, think about them as data structures, right? And they have fields. So it's just like class inside of Java, and they have fields. And so you can call like this, get the UID value by doing something like admission.uid, and then you get the UID value. And then this is allowed that I was talking to you about. This field is what indicates how the webhook server, what the webhook server does with your request. So if the allowed equals to false, so yeah, as you can see here, it says allows indicate whether or not the admission request was permitted. So if you set this value to false inside of your logic, that admission control is that request is going to fail. And there's still a couple of other things. So patch is optional, and patch type. So these are the two ways you can make changes. So a mutating admission controller would take advantage of this patch field to make changes to an object field. So if you're going to make a change to a pod metadata label, you would have to use a patch type. And pretty much patch, the patch operation is just like it's a way to make changes to JSON objects without just copying the old JSON payload and just making changes to it and passing it all back. So you can pick specific fields and make changes to them. And then the operations that I talked about earlier. So you can do a connect operation, delete, update, and create also. So if we go back into APIs package, there's also the admission registration, and we go into types of Go. And here you can see more information about the webhook configuration itself. So remember how we checked the rules, and we can specify the API groups, API versions. So you can specify the resources that you would like to intercept on. So here are some examples of what kind of resources. So you can specify pods and all the underlying sub resources of pods. Or you can do things like pod logs. And then you can specify the scope also. So yeah, you can say values are cluster, namespace, and star. And cluster means that that's only cluster scoped. So what else?
I mean, I have a question.
Go ahead.
My question is going to be like, for those that are looking to write admission controller for their use, how much is knowing all these objects in Kubernetes going to help them? And also, that's my first question. How is knowing about these objects, how is it going to help them? The second thing is for those who are not an expert or who are just getting started in Go, how should they go about trying to do this?
Yeah, that's a first thing. Thank you for asking that question. That's a great question. So to answer your first question, so of what use is knowing all this? This comes in handy when you're trying to determine what kind of operations or what kind of fields, what kind of information goes to a specific field or like a configuration. So you can come in here, if it's not inside of this place, then, Kubernetes can do it, but that webhook configuration can't do it. So for instance, the operations, if you take, for instance, the operations we took a look at.
I thought you were going to read a book, not like a...
I'm sorry?
Sorry, I didn't realize I was not on mute. Sorry.
All right, so no problem. So so for instance, if you wanted to confirm, the kind of rules you could specify, this is a great resource. Or it's great to know that this exists here, and you can come and validate that the things that you're trying to do are actually correct. And then as far as, a good starting place for people that are just trying to write their own admission webhooks, one great thing is to refer to the Kubernetes documentation. They do have they have documentation on how to go about this. And then there was also something I was planning on showing that could be very, very useful to people that are just starting to do this, which is the way Kubernetes itself tests the admission controllers. So if we go into Kubernetes right now, and you go into test and images, and then we go into the webhook folder. Oh, that's a big file. And we go into this webhook folder right here. So let's take, for instance, the add label.go webhook. So this is a very, very simple webhook. And so remember how I talked about the patch operation? So this is an example of a patch. So we're specifying operations here, which is add, and then the path, which is metadata, the label. And so in this case, we're adding values of add label and yes. So in this case, the metadata the patch operation here would add a value of add label, a key of add label, and a value of yes to that metadata. And so if you look at a function for the add label, it has this B1, the better admission review. So this is how, you remember how I mentioned that the admission review is sent. So it puts your logic inside of admission review and gets back an admission response. So yeah, so this is just a log. So, okay, yeah. So starting from this point here, we use this object variable to represent the meta v1 object metadata. So object meta contains all the information for like the object that you're trying to make changes to. And then raw here is just holding the raw request itself. And then we do JSON on marshalling to the raw object. And then, yeah, we specify the review response. So remember how I mentioned that the review response, dot allowed, the field allowed, which is a field for the struct admission response. If it's set equals to false, it means that deny that request, and if it's set equals to true, it means accept that request. So basically, yeah, it's saying that if the object metadata label is equals to 0, that is, if there's no label inside of the YAML file that you've specified, go ahead and add this metadata in there. And then there's also an else statement that says, do the second one. And so patch operations, you can do things like add, replace, move, remove also. Those are the ones I can remember right now. And so finally, we send back the review response. So this is like a very, very good place. This is a very, very simple example of like a mutation webhook, because it just has a label to the object. So this is like a very, very good starting point. Basically, all you need besides this is an HTTP handler that exposes your web server, and also a way to pass TLS sets to the deployments that you're going to be specifying. And then your webhook server also has to be listening on port 443 in order to be able to communicate to the API server. So yeah, this repo is like a really great resource and a great way to make those changes.
Yeah, I have a quick question. So, so for developing these webhooks, is the practice to typically use like client Go? Because like I'm trying to understand, like to work with this, like what is the development setup? Is it like just client Go? What are the tools that you would use to develop this?
So ideally, your webhook. So let me just state this, and I hope I'm answering your question this way. The webhook server could be written in any language. So all you just have to do is it's just a webhook server, right? All it's doing is just intercepting that request and doing something with it. And so let me show you, I'm going to show my code, like, so what the admission control webhook that I have written. So I'm going to show that, and it should make more sense what is required.
Okay, yeah, I can just hold off till then. Thanks.
1 second. If I can just move my, all right. So Claire, I'm just gonna close this terminal. And okay, 1 second. So two things are very important, right? This is my webhook.go file. So I'd written this in Go because, you know, Go is like a first-class citizen of Kubernetes. And so basically I exposed the packages that I would like to. So first, let me say what my deployment is actually doing, or what my admission controller is doing. My admission controller is basically, I have like a validation function and also a mutation function, a mutating webhook function inside of this webhook.go file. And basically what the validation part does is it says that if we don't have an annotation that I have defined inside of this code, inside of our deployment spec, inside of our deployment, reject that deployment. And then the mutation one says if there's a certain annotation, inside of the deployment, deploy that pod, change the namespace of that pod to production. So let's take a look at this. So I import a couple of packages that were required for this. The admission one, the apps v1, and meta v1 also. So then API machinery, and then klog. So some of the lines of this code were actually borrowed from the examples from the Banza Cloud folks. So they have a neat blog on using admission controllers. So I've just added some piece and just changed the logic. So I have a constant here called prod key, and I specify what my annotation should be. So this is going to be my annotation key, which is tunde.meetup.com/prod. And then I put this constant in here so I can use it for a patch operation. So whenever this prod key is an annotation inside of my deployment, I'm going to update the metadata field and add the namespace as prod. And then I'm also like using ignore namespaces to ignore any namespace that is kube system or kube public. And then we use this to hold the parameters for the port, the set file, and the key file. So these are the TLS for TLS purposes. And then this is the validation method. So yeah, we use objects to hold the meta v1 object metadata. So if you look at the object metadata field also, so it contains things like annotations, owner references, generation, resource versions, namespace, and the likes of them. And yeah, I'm specifying the kind of resource that I would like to make changes on. And also the package that I'm calling that resource from, which is apps v1 deployment. So if we go back up here, there should be apps v1 right here. So which is part of the apps v1. Where did I stop? Okay. Yeah. So then we do a JSON on Marshall of the raw request that we're getting. And then we return an admission response. And then, yeah, we say if the length of the object, so we say object that get annotation, that is, if the annotation field is equals to 0, that is if there's no annotation specified, we set the review response that allowed equals to false. So that's why whenever there is no admission response, that's why whenever there's no annotation, the response gets rejected, just because of this line. And then we return the review response because we expect the admission response at the end of this function. And same thing for the mutation part. It does pretty much the same thing, but if you look at this part right here, we say, there you go. So yeah, we say if this is true, review.patch equals to set prod namespace patch, which is adding the resource to namespace prod. And then we return the review response also. And then if you go to the main.go file, it just does all the parts for the HTTP handler part. So we pass in the parameters of the set file and the key file to the deployment. So we pass them as arguments to the deployment. And where are you? And yeah, this is just starting up the HTTP server. And then we specify the handler function for mutate function and also validate function. So if the path is slash mutate, it would go ahead and call this function. And if it's slash validate, it goes ahead and call this function. And then we use a go routine here to listen and serve. And this is pretty much it. A lot of this here is just like additional stuff that you don't really need to add to your own. This is just for verbosity and login purposes. So some of these lines you do not need to have in your own. So it's pretty much this main.go file and this webhook.go file, webhook.go containing the logic that you need. And then There's also this Docker file for Dockerizing the webhook itself. So we go ahead and so we start from Alpine latest and add that repo to inside of the Docker file, and then we create an entry point /admission webhook. And then there's also a build for building the image and then pushing it to the repo. So that's pretty much all that I had to have to actually create the deployment, to create the Docker image that I ended up deploying. So if we go back to a terminal right now. All right, so I've stood up a Kind cluster for those who haven't heard about Kind before. So it's kind of like it's a local Kubernetes cluster that you can deploy that allows you to have multi-masters and multi-worker nodes. So for instance, if I run kubectl to get nodes, you can see I have 2 masters and 1 worker, unlike Minikube where you have just one control plane running. It's not really realistic. So right now, if I run kubectl to get pods, there shouldn't be any resources in my environment. So first thing I'm going to do is I'm going to generate the certificate that is required to communicate to the API server. So I'm going to copy. So there's a script that I have that, and this is also a borrowed script from the repo that I had forked to make changes to. So it creates a certificate sign-in request. So right now it says pending and now approved. And so next thing, we run kubectl to get secrets. This is the admission webhook secrets. This secret is going to be exposed to the deployment via volume. And next, we're going to create a. Now we're going to create the deployment. So let's just so folks know exactly what I am making changes to. So I was going to create a deployment. So we go into deployment here. Where are you? Deployment here, YAML. Yeah. So this is the deployment.yaml that is going to represent my webhook server. So yeah, I'm specifying the image that I had built earlier. So this is that image that contains the logic that I had specified. So I'm going to go ahead and run that as a deployment inside of a Kubernetes cluster now. That is running. So let's run kubectl to get pods and confirm that is running. So far that is running. And then we're going to create the service that front end this deployment. And I'm going to show what that looks like also before running that. So let's take a look at the service. So hopefully folks can see this clearly. So we expose port 443, and that's pretty much all we need to do. The name of this service has to also match the name specified inside of the validation webhook configuration. So I'm going to go back to my terminal and then create this service. So we're going to run kubectl to get service and make sure that our service is running. As you can see, the service is running right here. The next thing we're going to do is we need so if you look at our validation webhook, this one, it requires a CA bundle. Since we already have like kubectl access to the API server, so basically what I just did was I just went ahead and ran kubectl. So let's check. So if you run kubectl config view, so dash -14. So I have this command somewhere here. 1 second. There you go. Yeah, this one. So if you run this command, you're able to get the certificate authority data and just copy this field right here, and then come into your validation webhook file and then paste it inside of here, instead of like just looking for another way to do that. So you can just copy that and specify it. So this is the validation configuration right here. So I'm going to change this to let's call this tunde.meetup.com. Okay, yeah, so everything looks good. We specified the service name, which is also matching the service we had created initially. And so upon a create request for deployment and services, if it doesn't have the annotation that we specified inside of the code, this would fail. So I'm going to save this. Let's take a look at. So yeah, let's create that. So we need to do. First, if you notice on this last line, here, we're specifying a namespace selector, and we're saying that basically what we're saying that this validating configuration right here is only going to apply to a namespace that has the key admission webhook and says value enabled. So right now I'm going to do a couple of things. First thing I did was I enabled the namespace default with that admission label that we needed. And also I ran a kubectl get namespace to ensure that that label was created. So next thing is we're going to create the validation webhook. So if we run, I'm going to copy this. We run kubectl get validation webhook configuration. So you can see that the configuration is here and everything is running. So now, moment of truth. So I have two deployments here. So update YAML. So let me unlock this. So can everyone still see this clearly?
Yeah.
Awesome.
Yes.
So I have the annotation that says tunde.meetup.com/prod equals to true in here. So if you remember earlier, I had shown inside of this file the webhook.go. So if you look at the validating aspect of it, which says that if the length of object that gets annotation equals to 0, that is, if there's no annotation specified inside of the deployment file, go ahead and set the response that allow equals to false, and then also show a message that says no valid annotation specified. So that is the expected behavior. I'm going to be honest, this hasn't been tested. So if this doesn't work, we're all going to test. We're all going to troubleshoot this live. So hopefully it works. I'm feeling. So we go back inside of this, and basically what I'm going to do is I'm going to copy this file. Actually, I do have another one that doesn't have the annotation. Yes, so this doesn't have an annotation. So what we're going to do is basically run kubectl create. Well, that wasn't expected. That should fail. So let's take a look. Kubectl create. Let's check if there is an annotation inside of that deployment. X -o YAML. So this is a problem. Let's see if this works. There you go. So did it let me do that? So let's run kubectl get deploy. So for some reason, this keeps on adding another annotation to it. So let's look for something else that wouldn't add an annotation. So let's run kubectl create. Actually, let's use kubectl run. Box. Dash image equals to BusyBox. And dash image. So I'm not sure exactly what I think it's image pool policy. Where are you? Okay, so dash restart. Never. Okay, that's weird. So that shouldn't actually do that. So let's see if we can. We might have to look at the code together. But while I look at the code and see, oh, sorry about that. Let's see why that is failing. So let's take a look at the validate function. we? Okay, so we said grab the deployment, return v1, say error equals to new, not equals to new. Okay, so we say review response equals to this. If length so why don't we do this? I think we still have time. Does anyone have any questions so far? So let's see, object to get annotation. So I'm going to cheat here and check what objects the meta v1 object. So,
Hey, Tunde.
hi.
So I'm curious, are you expecting any deployment to fail if it doesn't have an annotation, or are you just expecting this to change something that does have a specific annotation?
So if it doesn't, so right here it says, what I'm trying to do is if it doesn't have any annotation inside of it, just any annotation inside of it, fail.
Okay.
Oh, where are you? That's not it. Right here. So I'm saying that if the length of objects that get annotations equals to 0, just return response that allowed automatically equals to false. So what I'm going to do is I'm going to, if there's something I am missing here.
It looks like there's a missing, the lens is not being closed.
It's not closed?
Yeah.
Oh, wow.
The lens is not closed.
That's a good catch. So possibly, yeah, possibly that was the reason. I'm surprised this compiled. So, well, great thing is we get to fix this together. Who's excited about fixing this? So I am going to go ahead and recompile this. It shouldn't take too long. I have all packages, but while I am recompiling, so a couple of things I'm going to do first. So the sweet thing about kind is that you can easily do things like kind delete cluster and specify the name of my cluster, and voila, that's what it takes to delete my kind cluster, and everything I deployed is gone, and I can easily create a new kind cluster by just running kind creates this, and I'm specifying the version 1.13.4, and it spins up 2 masters. I have a configuration file that I'm passing to it, and it spins up 2 masters and 1 working node. So check out kind if you would like to be able to do something this cool. Just tear down and bring back up. So quickly, let's just recompile. So if you would like to see what it feels like to make these changes and see it work. So a couple of things I need to do. I'm going to go ahead and go into my build file, and I'm going to change the version to, let's change this to meetup fix, right? Let's just call it fix. Let's call it fix webhook and fix webhook. I call it V1. All right, so what's our webhook? So everything looks good. We made the change. What did I do? All right, yeah. So while we're here, I'm going to go ahead and do /build. Now first, let me make sure I am logged in. Okay, I'm going to do /build and make sure that, so I'm going to go ahead and build the Webhook.go, and also every of the other, build the Docker image also, and then push that Docker image to the GitHub repo. So while this is going on, I'd like to, if there's anything anyone would like to discuss on admission control while this is happening, I'm happy to talk about that now.
One question I had, would it be possible to kind of tail that container that's running the admission webhook while you're making the deployments?
Yes.
Just for debugging or visibility?
Yes. So yes, you can. Right now, I already tore down that cluster, the problematic cluster. So right now, I'm spinning up a new cluster right now. And surprisingly, this is taking longer because I have a lot of things that run inside my cluster, but typically this takes like 1 to 2 minutes and spins up your whole infrastructure for you. I typically spin up 3 master and 3 worker nodes with kind. Yeah, there you go. See, it wasn't planning on letting me down. And so basically, if I run kubectl get nodes, so anyone that missed the first part, we're just gonna do everything we did the last time, but in a much faster way. I do have all my configurations here. So one thing I need to change is I need to go back inside of my deployment file and make sure that we're pointing to the new image. So let's go into that new image, which is going to be inside of this deployment.yaml. I'm going to close this. All right. And then we're going to call this fix. And it should be v1. And then we save this. Nice. So that's pretty much all we need to do. We just change the image. And right, I'm deploying everything that is required for TLS purposes. And I created the deployments with the changes we made already. And then I'm also going to create the service. So that is done. And we'll go ahead and label Control Z. So we've gone ahead and labeled the namespace, and also we get to the namespace to confirm that we have everything. Awesome. And then we've created the validation webhook configuration finally. And again, we get a second try. So now we can run kubectl create. So let me make sure I'm in the right directory. So, okay. So kubectl create -f of no app. Where are you? And this should fail. Why is this not failing? So let's see. What are we doing wrong? What are we doing wrong here? So, so let's see. So get pods. And then I'm going to copy this admission webhook. And then run kubectl. Oh. This is why it's failing. It says TLS handshake, birth certificate. Oh, I know why. It's poor me. So the certificate that we're actually using right now is for the one of the old cluster. You remember I deleted the old kind cluster and I was using the kubectl set that it was using. So basically I'm going to go back inside of my, and whoever suggested checking the logs, thank you so much. And so let's go into the validation webhook. So let's take this one out. What did I do? All right. And then we're just going to go ahead and pick this part of the code. Copy. And then go back to the terminal. And I'm just going to copy that certificate authority data again. Where are you? All the way to L. Okay, I think I must have missed a line, but we can add that. And let's just confirm that it's the same thing. Yep, so I'm missing the L. And I'm gonna save this. And hopefully we should stop having the bad certificate error right now. So minimize this. All right. Okay,
And
let's.
if you're using K9S so that you could easily navigate through the kubectl commands.
So yeah, that's a cool tool to use also. But I do not have K9 installed right now. Or maybe I do. But let's check the deployment right now again. Let's see the logs and let's see if it's any different. Let's bounce the deployment. So I'm going to bounce the deployment, the pod, and see if it makes any difference. So kubectl delete pod. All right, so let's see. I'm gonna make sure the deployment is still running. All right, it is running. So I'm gonna delete this. Next. And then also check the logs to make sure that we are over. Let me say kubectl logs -f. All right, so far so good. It doesn't look like we're. All right, so it doesn't look like we're running into any issues. So let's create that pod again. Yay!
Oh yeah, nice.
Exciting. So finally we were able to get the admission webhook to do what we did. So that's awesome. So we're all able to troubleshoot and also run into some of the issues that webhooks can give you. You know, there's a TLS part. We're having a bad certificate because we recreated a Kubernetes cluster and we're trying to use the previous Kube client certificate, and that wouldn't work. So right now, because we do not have that annotation specified, it's saying that denied the request, no valid annotation specified. So technically, now that we have one that defines the annotation, that should work. Okay. I'm doing that. Let's see. Oh, this, it does have it. So we're specifying it right. What are we doing wrong this time around? So let's confirm. But I don't want us to dwell. I don't want us to dwell on that part right now. But I wish there was more time for us to go over that. But we were able to see that based off the fact that there was no annotations, we were able to send back a response. So I think that I was able to pass the message across on what you can do with the admission controller. And so,
yeah.
But I'll be sharing like a GitHub, the working one. So let me go back to the slide. So the big take home from this, what is going on? Where are you? What am I doing wrong? All right, so let's expand this. All right. So the big take home from this is, don't be a victim of your own configurations. Mutating webhooks can be very, very, and validation webhooks, they can be very, very tricky. If you have several of these in your Kubernetes cluster, it kind of changes the way your Kubernetes cluster works, makes it very, very difficult for someone new to join your team and immediately understand how your cluster works, because they could be using a Kubernetes cluster that was different and just working the default way Kubernetes works. And also, you could do an upgrade and then forget to make changes like to the certificate, like some of the things we run into here. And this can cause a very bad Friday for some people at work. So you don't want to be that person. So some of the references, Istio also uses mutation webhooks for injecting sidecar containers inside of every pod. So it injects Envoy inside of every pod inside of the cluster, taking advantage of mutating admission webhooks. But if you have any questions, now is a great time. Thank you all. Feel free to join our Slack channel. And also, if you would like to join us to speak in the future, you can go ahead and click on I'll be sharing this link in the Slack channel. Click on the link and just fill out the form with the topic you would like to talk about. And we'll get back to you.
Actually, I have a couple of questions. Maybe it's not directly related to the topic of discussion. So I have a Minikube running on my laptop, right? It's a Windows laptop, and maybe if anybody has faced this issue before, can chime in. When my laptop goes for hibernate and comes back up, what I see is the Minikube status shows that the API server is down. And the only way I can get it to work is delete Minikube and restart the VM. And it doesn't make much sense because the two other processes, the kubelet and one other process are up. It's just like the API server which shows us down. Has anybody experiences this behavior?
So it's been a minute that I worked with Minikube, but first I would like to know what you're trying to use Minikube for, and then maybe I might be able to suggest that you go ahead and quickly install Kind within 5 minutes and spin up a Kind cluster, and your life is automatically easier.
How do you spell a Kind server?
So I think someone shared the link in the chat room.
Yeah,
Okay,
Chris shared the link in the chat room.
yeah, Chris.
okay.
Yeah, Duffy had a talk for that in YouTube.
I'm sorry?
Duffy did talk on Kind in the YouTube channel.
Yes. So if you're not familiar with TGIK, I think it stands for Thank God It's Kubernetes. So there's a link. You can search for it on YouTube, and you can find really nice videos on Kubernetes concepts, and you won't regret going through them. But as it relates to admission webhooks, does anyone have like any experience working with admission webhooks that has driven them crazy, or they've run into any interesting issues, or do you now, after this meetup, see a reason why you might want to use admission webhooks, or why you don't want to use admission webhooks?
I mean, for me though, right? So one thing I get away from admission webhook is, if you are going to use it, you better do it right. And you better make sure that it's highly available, right? Because the admission controller sits in front of the request. So if the webhook is down, if the webhook is running in your cluster is down, right? The port that is serving requests to the webhook is down. So all the ports that is supposed to replace those ports are not going to be able to come in. So you are in a very big spot. You have to make sure if you are doing it right. If you are doing it, you better make sure you have the knowledge and the experience to get it right the first time. To make sure it's highly available. And Istio uses a webhook a lot. That I've used Istio in QA environment. And one thing I've realized is going through the code, it's a lot of effort to make sure testing is in place. Make sure you have testing in place. And that is why I'm not planning to deploy webhook in my environment anytime soon. Because it's extra management, especially if it's possible to use something someone else in the community has written, something the community is developing for this, I'm going to recommend that over spinning out your own solution. I'm going to really recommend that.
Well, so operational complexity comes with using tools like this, but as engineers, what keeps your job, what makes you keep your job is, you being able to manage this operational complexity, right?
Yeah.
So, like Kubernetes, you can make the same argument for what you said about Kubernetes also, because Kubernetes is complex and or can be complex, and it just depends on how you use it. Enough testing, having plans for upgrade, and all this downtime, as you mentioned. So, today, the only one way to govern your Kubernetes cluster and make company-wide decisions is to take advantage of admission webhooks.
I had a situation whereby one of our security guy was planning to use admission webhook for some security reasons, and this guy, I would say, he probably cannot write a full deployment manifest. so when he told me he wants to use admission webhook, I asked him, is this something that you are fully sure it's the only solution? and you have the technical knowledge like to maintain, right, in the cluster, right? It's a dev cluster, it's not a production cluster. That's it. But he said no. So I said, no, there are other solutions online, right? I did not volunteer myself. I could have. I did not volunteer myself for maintenance. And also because we're using things like EKS, I really didn't know how Admission Webhook is going to like deal with when you're upgrading cluster like EKS, right? As you can see in this case, you were able to do things like obtain like how do I say this? The TLS data, right? How does that work with your cloud provider? So those things have to be put into consideration before going ahead.
That's right. Yeah, so admission control is a beast on its own. It's like it's very, very powerful. I mean, you know, if you're going to take advantage of things like mutating webhooks, you want to make sure that, you know, there are strict RBAC rules in your Kubernetes cluster, and who can go ahead and make changes to that, to the mutating webhooks themselves. So take, for instance, I could exploit or cause a lot of havoc in the Kubernetes cluster by changing owner references of deployments. So if I deploy today, if you create a deployment inside of a Kubernetes cluster, right? That deployment has an owner reference field, and every pod that encompasses that deployment as that is referenced by that owner, right? So what I can do is I can write a mutating webhook that copies that takes the owner reference for that deployment that I've created and map it to every other deployment inside of a Kubernetes cluster. And all I need to do to delete everything inside of that Kubernetes cluster is just run a kubectl delete of that deployment, and it deletes everything that is referencing that deployment. So you really want to be careful with mutating webhooks or admission controllers in general. I ran into a customer issue where they had an admission controller in the environment, and the deployment that was managing that admission controller was not running, or there was something wrong with the deployment, and for some reason they couldn't create any resources. So what happened was that the way they noticed was that one of their pods went down and it couldn't scale back up. So what would happen is Kubernetes wouldn't tell you that, you know, your application didn't deploy. Basically what is going to happen there is the desired state versus the current state of this conflict inside of the cluster is going to be 0. And that was just a state, that was just what happened. And the problem with debugging this was that there was no output or log that was telling us that this is the reason why. And the challenge is, you as a Kubernetes operator, you start to see patterns inside of the Kubernetes cluster that, oh, you're thinking, well, maybe there's an RBAC rule that says do not create, do not update, because if you take out a create and update rule from the RBAC, you get the same behavior, because whenever you create a deployment, basically what's going to happen is the current state and desired state is going to be 0. So when I was troubleshooting that was what I was thinking. But then what I did was I increased the verbosity of kubectl, and I still didn't get enough information. So what I ended up doing was using the call command to make a request directly to the API server. And what I realized is that there were a lot of uninitialized objects that were stuck in pending state. So basically what happened was that there was a pod, there was a Spark operator pod that was adding an initializer on every single pod inside of the Kubernetes cluster. So each pod that was trying to create had a pending was initialized with a pending, and they were all stuck in pending. And so no resources could be created inside of a Kubernetes cluster. So just be careful with using admission controllers.
I have a question. So is it going to be advisable, like, what would be the best option? Running the web server within your cluster, right? Using like an external like highly available server. What would you recommend?
So when I think about it, the problem with running it outside of your Kubernetes cluster is you have to run it in tandem with your API servers. So it can run, you would have to make sure that Webhook server can communicate with every single API server. So for example, think about it. You're not communicating with just one API server in a production environment. That is, if you have HA Kubernetes cluster, right? So you have to constantly deploy that. And then there's also the aspect of Kubernetes that you're missing, the scalability part, whereby what happens if something, let's say an AZ where, or a single AZ where the deployment or the webhook servers are running go down. So basically you can't create resources. You have to go ahead and generate new sets and do all that all over again. So that's the problem. That's one of like the biggest problems. So
That makes sense.
Unless anybody has any other experience on challenges with running it outside of Kubernetes, but that's the only one I am aware of. Well, I think we've come to great stuff today. I actually finished this earlier than I thought. Thank you so much, everyone, for joining. I really enjoyed your questions. I enjoyed, us all troubleshooting webhooks together and seeing the challenges of working with webhooks. And coming months, so actually in another month from now, I'll be doing a talk on networking in Kubernetes. So if you're interested in looking at networking in Kubernetes, please tune in and let's do this again. So thank you so much for joining. We would like to get more people to come in here to talk. Feel free to sign up on this slide here and just come and share your knowledge.
Thanks a lot.
Thanks to me.
Thanks, guys, for coming. Really appreciate this.
Thank you all.
Thank you. Take care.